Hi, Assalamualaikum and good day. Today you are going to learn on how to solve system of linear equations. Following is the objective of today's lesson. By the end of this session, you should be able to solve the n by n system of linear equations using adjoint method and Cramer's rule method. A system of linear equation can be represented in matrix notation Ax equal to B, in which A is the matrix of coefficient, X is the vector of unknowns, and B is the matrix of equation values. If matrix B equal to 0, the system is said to be homogeneous. If matrix B not equal to 0, then the system is said to be non-homogeneous. For a system with the same number of linear equations and unknowns, that is n, the system is known as n by n system, in which matrix A is a square matrix. For a system with m number of linear equations and n number of unknowns, the system is known as m by n system, where A is referred to a non-square matrix. To solve the n by n system of linear equations, you may use the following three methods, such as 1. Adjoint method, which is also known as inversion method, 2. Cramer's rule method, and 3. Gauss elimination method. However, to solve the m by n system, only Gauss elimination method that can be used. Adjoint and Cramer's rule method are not applicable because this method involves determinant, which is only defined for a square matrix. To solve the system using adjoint method or inversion method, you need to apply the formula x equal to the inverse of A multiplied with B, which is equal to 1 over determinant A multiplied with the adjoint A multiplied with matrix B. Refer to example 28. You need to solve the following system of linear equations using adjoint method or matrix inversion method. To solve the system, first of all, you need to represent it in matrix notation, that is Ax equal to B. As this system involves three equations and three unknowns, which are x1, x2, and x3, matrix A here is referred to as square matrix of order 3. To find the determinant, you may use the cofactor expansion or minor expansion along the first row, which is A11 minus 11 minus A12 minus 12 plus A13 minus 13. And you should get 6 as the answer. As the determinant is not equal to 0, that means the inverse of A exists. Next, find the adjoint of A, which is equal to the transpose of the cofactor matrix, which can also be written as the transpose of minus 1, 1, negative minus 1, 2, minus 1, 3, negative minus 2, 1, minus 2, 2, negative minus 2, 3, minus 3, 1, negative minus 3, 2, and minus 3, 3. By deleting the corresponding rows and columns, you will obtain the following minor. By cross-multiply the elements in each minor and subtract, you will get negative 16, 26, negative 11, 14, negative 22, 10, negative 6, 12, and negative 6. Transpose this matrix, you will get the answer for the adjoint A, which is negative 16, 14, negative 6, 26, negative 22, 12, negative 11, 10, and negative 6. Substitute the answer accordingly into the formula of x equal to 1 over determinant A multiply with the adjoint A multiply with matrix B and simplify. You should get the answer for x1 is 4, x2 is negative 2, and x3 is 3. Let's proceed with the second method, which is known as Cramer's rule method. Cramer's rule uses determinant to solve system of linear equation. Cramer's rule can solve single variable at a time instead of solving the entire system of equation. Let D be the determinant of the coefficient matrix. Then dx or d1 refers to determinant formed by replacing the first column of matrix A with matrix B. dy or d2 refers to determinant formed by replacing the second column with matrix B, and dz or d3 refers to determinant formed by replacing the third column with matrix B. To obtain value of each variable, x equal to dx over d, y equal to dy over d, and z equal to dz over d. If the question used x1, x2, and x3 as the variable, x1 is equal to d1 over d, x2 equal to d2 over d, and x3 equal to d3 over d. Under Cramer's rule method, if D is equal to 0 or determinant A equal to 0, the system is inconsistent and has no solution. However, if D is not equal to 0, the system is said to be consistent and has unique solution. Unique solution here means each variable has one definite value. Refer to example 29. You need to solve the following system of linear equations using Cramer's rule method. To solve, first represent the system in matrix notation AX equal to B. See that matrix A is a square matrix of order 3. Let D be the determinant of matrix A, which can be obtained using cofactor expansion or minor expansion along the first row, which is A11 minus 11 minus A12 minus 12 plus A13 minus 13. You will obtain 42 as the answer. As the determinant is not equal to 0, the system is consistent and has unique solution. As the variable involve x1, x2, and x3, you need to find the answer for d1, d2, and d3. d1 refers to determinant formed by replacing the first column of matrix A with matrix B. By solving this determinant, you should obtain negative 84 as the answer. Next, D2 refers to the determinant formed by replacing the second column with matrix B. By solving this determinant, you should get 0 as the answer. Proceed with D3, which refers to determinant formed by replacing the third column of matrix A with matrix B. Solving this determinant, you should get 42 as the answer. To obtain the value of each variable, x1 is equal to d1 over d, x2 equal to d2 over d, and x3 equal to d3 over d. Simplify the answer. You should get x1 is negative 2, x2 is 0, and x3 is 1. In the next lesson, you will learn on how to solve the system of linear equations using Gauss elimination method. So,